Buongiorno.
Good morning, Garry.
Good morning, Gerald.
I hope you had a nice trip here to Berlin.
I did, thank you. You've been most hospitable as well.
Okay.
Thank you very much.
What are we going to talk about today?
I think we should talk about your valves.
Okay,
These ones in particular.
in particular.
Yeah.
Well, I guess you're having some questions about my product.
Yeah. Valves are not just valves, clearly by the fact of what you're producing. So what exactly makes your valves different to all the other valves?
Well, I think first of all, it's the way they look, the way they are designed.
Yeah, I've been told they look quite military style.
Yeah, I love that. I love that, yeah.
Yeah, I think most of the guys love them as well, and the women.
Yeah, then furthermore, we're using excellent high quality raw materials.
Mm-hmm.
And the third point is that we're working with very, very small tolerances.
Yeah.
So this actually makes our valves to last very, very long.
Yeah, that's actually very important. From my point of view, as a cave diver, instructor, somebody who likes going out on expeditions and exploring. So what I really want is equipment that I feel safe with. I need to rely on my equipment. We've got our own training, but what we need to be sure of is that wherever we go, our equipment's going to work, it's going to last. We don't want any nasty surprises on the day.
Yes.
So can you tell me what in particular about the materials you use that makes it last for so much longer?
Yeah. The Americans would call the brass we use a military grade material. Okay.
Sure.
Yeah, but it's not actually no secret, but our alloy contains a lot more copper than regular brass. Mm-hmm. It contains zinc. And instead of lead, it contains about 3% silicone plus a small portion of phosphor.
Okay. So basically removing the lead and I've got a little bit of a chemical background myself, but so removing the lead, which is quite soft, you've got a stronger material, which is the silicon, and it's also got like graphite kind of capabilities as well. So it's kind of smooth at the same time.
Yes.
So you've got hard and smooth.
Hard and smooth, that's correct. And, but it's a material that is very critical when you are machining it because it's heating up real quick. Mm-hmm. And opposite to the tolerances I already mentioned that are very small, we have very high tolerances that we have to stay with when we are cutting threads.
That's quite typical of German engineering, I believe. Yeah?
I don't know.
Definitely so. And it's very obvious. I mean, I actually use your valves, and I've been using them for over 2 years now. So when I'm using them, I can feel the lack that tolerance. So it's so tight but smooth. In fact, I can actually say that normally when pressures drop in a cylinder, the valve becomes much more easier to turn. But at the start of the dive, when you've got the highest pressure in, it's actually just as easy to turn. So it's super smooth, super nice. Mm. It's not too easy to turn that it would accidentally go and move on it all on its own without very little effort. But what it does do is just provide a significant amount of turning ability, but it's just smooth and nice.
Yeah.
I like that.
Thank you.
One of the other things I'd like to mention about, which is one of the improvements that you've made on your valves, is that the ability to support higher pressures of oxygen running through your valve. So can you tell me more about that, please?
We experienced that divers were using regular valves that were supposed to operate with air, also for oxygen, pure oxygen. And they are actually ignoring, or were ignoring, the standards that we have to use 100% pure oxygen only with M26 threads.
Yeah.
And so I made the decision to manufacture all valves that we sell 100% oxygen compatible.
Yes.
Of course,
That makes perfect sense, by the way.
this makes perfect sense, but of course, this counts only when a valve is brand new.
Yeah. Once you contaminate it, then obviously it needs oxygen cleaning anyway.
Yeah.
But I think from that point of view, from a diving point of view, a lot of divers I know I've come across have actually expressed their concern about not sure whether they can use any amount of high-grade oxygen gas in their cylinders because they don't know enough about them or don't trust them. I think it's much nicer to know from our point of view that valves, cylinders, regulators are actually O2 compatible throughout without that problem of trying to decide what is or isn't. So
Yes.
I think that's a really, really good move there.
Yeah.
Thank you.
Yeah. And one thing is very important. It's not only that we made the decision to use this particular materials to make it oxygen compatible. We have it also approved by BAM, by an institute here in Berlin.
BAM,
That
yes.
BAM, that who are testing the valves under operating conditions in different temperatures with different temperature
Conditions.
right.
Environments.
Environments, yes. So, in this testing process, we also found that it has been necessary to use two different materials for the two different pressures that diving gear is working with, up to 230 bars and up to 330 bars.
Yeah.
So we finally achieved certification
Yeah.
for 230 plus 330 bar operating pressure.
Yeah, that's brilliant, and what a really good move just on the realms of keeping things safer, which keeps divers safer. So the improvements that you're making on the valves are just a massive plus for the whole industry. So thank you very much for that. The other thing that would be really interesting to talk about, which is part of what people are asking me, what's different about the valve on the inside? So it's kind of difficult for me to explain it, but now that you've got the actual parts with you here so we can demonstrate it, the difference between the typically older style or common style of valve spindle to the valve seat and your valve spindle to the valve seat. Could you explain a bit more about that, please, and why you did it?
Well, I think everybody is familiar with the common way to make seats and
Spade connection, yeah.
and of course, if you're applying high torque, this
pressure.
seat, is a critical part. It may break. So I said to myself, well, why not just take an Miller hex inside and connect it with the Allen key or
for sure.
Allen key type of spindle.
Yeah.
We have tested this here at BAM, and you are able to apply 80% more torque to it than to a common spindle.
For sure. And
Yeah.
again, my
80%,
background,
80%.
my background, believe it or not, being the mechanic and then engineer as yourself, basically when you try to use a flat screwdriver on a head,
Yeah.
it's a lot more temperamental than it would be to use an Allen key head. And again, even more so over the years, when people have used mechanical tools for taking hexagonal nuts and bolts off the equipment, off the parts, they tend to take off the corner so that the corner has less heat on every corner of the hexagon. So this was also something of a design for the snap-on tools, for example, that seemed to be very much more of a technological breakthrough, which is why we ended up with rounded heads of nuts and bolts that caused problems for mechanics in the future. So this is another great idea, and you've now supported it in your valves as well. So fantastic. So the other thing I'd like to talk about, your valves look so different to everybody else's, and they don't. Yeah, let's be straight. They look like military valves. The hand wheel, the rubber, the design of it, and of course the position of the outlet. You know, your main outlet, your G58s or M26, whichever. They are the position and height in relation to the spindle and the central body of the valve. Why is that so different?
Why is that so different? I cannot really tell you. I mean, the dimensions of the internal parts were given from the very beginning. So I didn't want to come up with a complete new valve, you know, with all different parts. And what would I do with all the customers who already had a valve with this internal parts? You know, this would confuse everybody. So I tried to make the best out of it, what I had, dimension-wise. But of course, if you want to sell a product and you give it or you hand it out to a customer, the haptic has to be okay.
Yes.
So he has to feel that,
Feel
well,
the
this
difference.
is
Feel
my
the
product.
quality.
I'm not going to give it away anymore. I want it.
Yeah.
And you can test yourself. Just take
I've
a
done
regular, okay. And a lot, of course, is helping our Pro line knob with the two rubber rings.
Yeah.
It's very comfortable to touch, and you have really good grip.
Excellent grip. The ergonomics of that valve is super. I dive both rebreather, side mount, back mount, and whenever we touch those valves, it's suddenly just got this beautiful tactile haptic touch that is definitive, and you don't accidentally slip with the other valves. Yeah. And again, the tolerances when you handle the valve, the tactile touch, that tolerance is much less movement when you come to turn your valve on and off. So excellent. So Gerald, when I received my valves from you 2 years ago, I got this rather weird looking contraption inside the component with the components. And I looked at it and I really had to ask you what it was. So let me just remind you. Okay. Here it is. What is this? I know what it is, but please tell me some more about it.
That's a very, very simple.
It's a microphone.
Filter.
It's a microfilter.
It's a microfilter, yes. It actually, as the name is already telling you, it filters particles up to down 2 microns.
2 microns.
2 microns, or let's say 3 to 4 microns.
So tell me what kind of micro particles that would
well, in
account.
diving, it could be rust from a steel tank.
Yeah.
It could be aluminum oxide from an aluminum tank, which is also very critical regarding your health when you inhale that.
Yeah.
And
Especially salt water.
Especially salt water, yes. And of course, it prevents internal freezing, first of all, of your valve, and maybe of the first stage of your regulator.
Okay, so not only are we able to manipulate a valve from a free-flowing regulator from the first stage to the second stage, but we're also helping it by way of putting a microfilter in there to stop the actual gas from freezing as it's leaving the tank under high flow and pressure.
So let's say you are having moisture or even water inside the tank, which happens a lot. You will have, under very cold conditions, you will have this moisture or this water freeze inside your tank, but it won't get into your tube and clog it up.
Yeah.
It will form around the filter. You find ice block around the filter element. But because the surface of this filter is this large, all the gas, the breathing gas, will go through it, and you will be able to continue breathing without any extra or additional resistance.
Yeah.
So the airflow or the gas flow will not be blocked. We came up with this idea in the late 1990s when the industry started to test regulators regarding do they freeze up in cold water conditions or not. And there were many, many regulators in the market who were not suitable for cold water diving.
For sure, yeah.
And we considered cold water diving from 10 plus and below.
10 degrees.
10 degrees, yes.
It's quite interesting because it's a very similar idea to a catalytic converter. So the actual surface area, if you were to lay it out of a catalytic converter, roughly equates to about the size of a football pitch because of the extreme amount of surface area that you get from every small part of that catalytic converter if it was ironed out onto a floor flat. And this is what you're saying, I believe, the same idea with the microfilter, that such a micro surface area, when laid out, gives you a much, much bigger space. So it allows more gas to come through and protection. So you get such a massive protection from inside the cylinder before it actually leaves and goes into the first stage.
Yeah, that's correct, yes.
Yeah. Okay. One of the things that we as the consumer, the diver, we like to know about such safety products that manufacturers make is that how much testing, how much belief do we have that the products that we get in a nice shiny box have been tested before they arrive and we put them on our equipment? So could you explain a little bit about how you test your products before they leave your factory?
Well, here at our factory, it's mandatory that we test each valve. And testing procedures we established are that, first of all, we do an external testing. What we call external testing is that we close the outlet and slowly increase the pressure from, let's say, 10 bars to 300 bars, and monitor if the body is okay. Because sometimes you can have foldings in the material and a valve can explode. And after a valve passed this test, we do the internal testing. That means we are opening the valve again and closing the seat and monitor if the seat is working all right. That's actually the test procedure.
Yeah, cool.
And all valves are tested, highest pressure test pressure is 300 to 330 bar.
Gerald,
Yes.
I'm sure everybody watching this has been dying to see what is inside this case. Shall we let them find out?
Okay, we let them know now.
Come on. Okay. Oh, there's a pink valve knob. I wonder where that appeared from. That's mine. Okay, let's go and have a look at these. Okay, so what do we have here? So for starters, we have the standard valve, which is absolutely beautiful ergonomically and visually. It's a stunning piece of kit. Here it is. You have your opening here, which is going to attach directly onto your manifold, like so. It's almost like putting a rifle together. So, and then you have obviously the other valve that fits onto the other side to complete the manifold. Okay, so if you don't want to have the manifold, and particularly when you're diving with such configurations as I do, chopping and changing between various parts, we then fit the blanking plug in here, which is completely secure, 2 O-rings, and then the cap over the top, which is completely independent from the rest of the parts. So that continues to wind on. We also have the ability then, let's look at the other parts here. And if you did find it slightly difficult to remove these with wet hands, if, for example, that would be the case, you could then use this part and screw it inside here and pull it out like so. It's quite a clever little piece of engineering going on there, I might add. And the last thing on here is your dual outlet valve, which again fits in here just like on the manifold. And then you have your dual outlets. This one's already got a current blanking plug in there, just to protect the outlet. Okay, now the other part on here we have is your microfilter. And the microfilter basically unscrews out of here, put this down, and it screws into the base here, obviously tightened with the right torque fitting settings, and screwed into the bottom here, and that would sit inside your tank. And that's probably the most safest valve I've ever seen. Well done, Gerald.
Thank you. Thank you for this compliment.
So the other thing I wanted to ask you about, Gerald, was the different types of finish that we have here, and this one being the rather nice military black looking style. Yeah. Mm-hmm. So tell us about that.
Well, it's a special anodizing process, and it's handmade. And because it has to be handmade, it's very, very time consuming and expensive. Mm-hmm. We have average lead time to do this job on this products for about 2 months.
2 months, yeah. Wow. That's a significant amount. So people need to get them booked in advance. Well, in advance. So this is the black chrome.
That's
and
black
then we also
chrome,
have the silver chrome as well.
Right. We are going to market it as Apex. Mm-hmm. Manifold set.
APEX.
APEX. Well, like the name says, it's top of the notch.
Yeah, definitely top of the notch. Apex, as in the highest it can be, the highest product it can be, which is very apt really, because it definitely is more in terms of safety from our point of view. As well as looks, which are always secondary, but the functionality, as I've said before, as a expedition diver, cave diver, we do need to make sure that our equipment is safe.
Yeah.
And we trust it, we have confidence in it, and that allows us to do our job.
Yeah.
Safely.
Yeah, you're absolutely right.
Well, Gerald, thank you very much. One, for the tour, inviting me over here, and this interview.
Thank you for coming by. Yeah.
And thank you very much. It's been an absolute pleasure.
Pleasure.